Hello everyone and welcome into yet another live stream, and wow, we've got quite a few people here today. Hello everyone, hi there, how are you all doing? I'm so glad to hear that you're doing pretty well. I'm so glad to hear that Kara is you're good too. Hi there everyone. Wow, I feel like this is one of the largest stream start so far, and I didn't scrap anything. I had the music ready, I was ready when it comes to audio. The 3D Make It is in the corner, and what's even better is that I even prepared this already. We already have all of these freaking things. Hi there, welcome into yet another my favorite 3am streamer. Hello, Make It. I hope you're happy. And say, oh, I'm very happy. I'm fun. Why don't you have 20,000 subscribers yet? I don't know. People don't really care about my videos all that much. Most people really like the addition to quantum mechanics and then nothing else. Atomic introduction sounds cool. Oh no, we've already been over this. Actually, fun fact, we've already been over. I think that's where we finished, right? Why don't electrons fall into the nucleus? We're actually moving like what a graphic. We're actually moving forward like crazy. You had 14.8k like months ago. Yeah, what's happened? I told you no one cares about my videos. I love your vids, all of them. Well, you're in the minority, right? You can't say it. Working on it. My pet project of mine. Anyhow, as always, by the way, in case anyone's curious, in case anyone would like to do some reading in their own spare time, first link in the description is this precise textbook. Libratex Engineering, about material science. Why am I writing capital? Because it's exciting! That's why you're writing capital letters, because the live stream is exciting, we're having fun, we're excited. Oh wait, should we start with Paul? How's the collab bit going? It's going actually pretty well, really well in fact. I'm really satisfied with how it's going. This is with Paul. Hold on. What poll should we make? You know what should we be asking about? What's on y'all's mind? What are you thinking about? You know what? Oh, you know what? I'm gonna ask a good question. What should I research more? We're gonna have chemistry. We're gonna have electricity. We're gonna have add some more options. Macroeconomics. Video playing while studying. Good luck studying then. Collab? Yeah, I'm working the collab. And we're actually I feel like this collab video is gonna come out this week. I think so, at least so far. I'm having a lot of trouble with rendering. Rendering is really slowing me down significantly. But oh well. There we go. That's the poll for today. Oh, we talk about the spin. Oh wait, we went over the spin. I just remembered. Oh, I don't. Oh, that spin chapter. We kind of glossed over that because I thought it wouldn't be important. Good luck you too. Yeah, we're gonna be studying parallel. You should show us a frame of the collab that is rendering right now. Oh, I'm not rendering collab right now. I'm rendering a video which was supposed to be out 2 days ago, but I've been rendering it non-stop. You wanna see a frame from that video? There, I can show you there. This is the video I'm rendering right now. Frame 10,065. This is the... Okay, for this animation, I have rendered around 20,000 frames so far. So, just in case anyone is curious, hold on, I'm just. That's what I'm. And that's not the collab video. That's just something I want to upload in the meantime, kind of setup. Just in case anyone's curious, that's around 20,000 frames divided by 24 frames a second. So that's how many seconds divided by 60. So around 13 minutes of animation non-stop rendering. It's a lot. In his background, yeah. This is still rendering. And this is one of 2 animations that I'm rendering right now, actually. The other one being this. This is the other one. 11,000 frame. Because I'm so efficient, I'm even rendering multiple animations all at once. This video was supposed to be out 2 days ago, but it's been rendering non-stop. Non-stop. Literally non-stop. Not in the figurative sense. Literal sense. The other reason I downloaded Unreal Engine 5, I'm liking it. As in for game dev or for rendering. How long does rendering take? Depends. Depends on the animation. Sometimes I can knock out like 5 minutes of a video in a single day when it comes to render time. And sometimes 1 minute takes a week. So, you know, it depends. Unreal just got a really cool new update. I'm sorry, I'm a Blender fanboy. When it comes to animating and 3D rendering, I'll use Blender because that's just my... I love Blender. It's open source, and how can I say no to that? Blender to Unreal Engine is what Linux is to Windows. I spent hold on, I need to put down some batteries. I spent 1 hour 45 minutes on it, and I was on it, and I was 8 minutes in a 2-hour-long vid. Yeah, but it's a complex tool. A source available, is it? Unreal Engine 5 source. I need source code, obviously. Is it really open source? Hold on, repository is 12, let's see. This is official Epic Games, so I'm guessing Epic Games should have it, right? Wait, is it really? You have to sign up. Ah, that's cringe already. Come on, you have to sign up. What kind of open source is that? That's cringe. Blender GitHub. There, that's what I mean when I say open source. Oh, you wanna see how it's rendered? Intern? It has an intern. It has an intern folder. That's what I mean by open source. It takes 5 minutes. Too long. Too long. Cringe. 5% in C. That's surprisingly low. I guess most people prefer C++, right? I'm just too much of a blunt fan. Takes 5 minutes. Oh my goodness, make it coding. No, I'm not. We're just. Although soon I might do some coding live streams. Wait, let me ask. Hold on, because I was supposed to do something with Tefta. Oh wait, wait. Hold on. Oh yeah, I was supposed to code something for Tefta. I won't get in detail on as to why. Tefta. By the way, So we might do some coding live stream soon. Yo, teach me Unreal Engine 5. I don't use Unreal Engine 5. How'd your Discord server grow? Addition mechanics. That singular video is responsible for 98% of my channel. What's your favorite coding language? C! I am a psychopath. I mean, a C programmer. What's the difference? Am I right? This schedule is cursed. Well, whoa! Isn't it like in the middle of the night for you currently? Wait, which way is it? I'm not good with time zones. It goes backward with... Too confusing. Never mind. C and Rust are both cool. Well, you know, as a C programmer, I am contractually obligated to not dislike Rust. This is the thing. When you program in C, you have to sign an agreement which states that you will dislike Rust. So yeah. You are a 60-year-old man. C is great. Come on, you can do manual memory allocation. I mean, it's not that big of a secret that my favorite is C, is it? Oh my goodness, this website. I don't like the fact that like search engines usually there. That's so sneaky. Oh, it's probably because I'm using dark mode. That makes sense. Ventum engine. There we go. Physics and mathematics. Oh, electricity 29%. That's cool. GitHub, mate. You mind? There we go. The repository code. Why? Since when? Since when is that a thing? Oh, that's BS. GitHub Ventum engine. That's BS. Since when is that a thing? There we go. That's my boy. Like, it's not a big surprise that I'm a C programmer, is it? What's your name, Casper Ojo? Oh, damn it, I've been doxxed. I'd rather write machine code than C. You are... They're both femboy languages, so I think there's an alliance or something. Actually, unsaved ROS also allows you manual memory allocation. Yeah, you nerd emoji haver. But can you... Okay, 4% of this has been written in assembly, by the way. Oh, I forgot I really did that. I forgot I like included so much assembly for no reason. Like there are so many functions here which I just coded in assembly for absolutely no reason. There's absolutely like no benefit to it. There's absolutely no benefit to having them as assembly. I could have just done them in C, like a normal person. I just did it for the sport. Anyhow, are we getting into the... Okay, we have 38% electricity. That's interesting. Okay. Material science. This is material science with electricity. So, we're doing half of that already. The reason why I included electricity as a separate thing is because in the future, next topic I'd like to research is solving circuits. No one writes assembly better than C compiler. Yeah, I know, right? There is no point. There's no point for writing assembly. There's absolutely no point. I am fully aware of that. As I mentioned, I just did it for the funsies. Like, I got bored of C. And I just switched to assembly. There is no reason. Although I am pretty certain that when it comes to that code, the compiler would write it the same way. Because it's very short functions, so there isn't really much room for optimization. It's like hyperbolic tangent, for example, and stuff like this. Why am I talking about this? Actually, I can show you. Hold on. Look at me going the way I hug. It's source math this. So, for example, you have hyperbolic tangent, which looks like this. Learning to read assembly though, it's good practice for you, I guess. It's not useful. I personally like Python and C#. Yeah, Python is decent. Python is like a jack of all trades, I would say. So this is, for example, hyperbolic tangent using... I don't remember the method. But what's really fun is optimizing an assembly. Boy, that's fun. Do you have lead code? I don't know what that is. Hold on, let me DuckDuckGo that lead code. What's lead code? No, I don't. Okay, I just looked it up and I still have no idea what that is. Hold on, what is lead code? Hi there, Andy. Code for sleep. Wait, what is lead code? I don't get it. Best platform to help you enhance skills, expand your knowledge, and prepare for technical interviews. Is it like a learning platform? Interview programming questions. Ah. Whoa. Okay, Cisco, maybe. No, you know what, never mind. Whoa, how cringe. Also, they have Facebook's logo. Isn't it Meta now? I forgot to update. Code problems, all of them very fun. I mean, you know, as a C programmer, I would say I already have enough code problems to deal with. Anyhow, I might remake MKT Multi-App in the future soon, though. I might remake it, pun intended. I already found someone who is like a cool programmer on YouTube, but they don't want to collab with you. So I need to get famous and then collab with them. Into Conglines? Oh my goodness, are we gonna turn the entire live stream to just Googling programming stuff? This is not a programming live stream, guys. We'll do a programming live stream soon. Constructed language. What is that? What is that? I don't. Why does it have a flag? Why does it have a flag? What is this? Having developed naturally and consciously, but it would remain good dividable configuration. I don't. Is that what it? Conlang. There, what is this? It is designed to express more profound levels of human cognition, briefly yet overtly and clearly, particularly about human categorization. That's just called math. It's cross between a pre-physical and okay, so this is basically English for people who do math, right? Yeah, so this is basically optimizing English language, which is really cool, but I don't think it's something that... I mean, it does look cool. It's a very cool concept. Philosophy language, that is cool. A prison, so that is really cool. I really like the concept of optimizing language. Anyhow, I feel like it's about time. 20 minutes in, I feel like it's about time that we get into the actual live stream. What do you all think? Let me just check up on a couple of renders. There we go. All right. You should make your own coding language and compiler. I don't want to. It's difficult. Well, it's not difficult. It's just... It takes a lot of work. Make your avatar do a backflip. I mean, I could just. It can take a lot of work. I already wanted to make an animation. One stream, I basically wanted to make an animation of 3D Make It dancing on Injustice. How about your own file format? He did that at least. I did so many of my own file formats. I made my own image file format, my own data file format, my own variables file format. I've made so many file formats. Vector graphics file format, that was also a thing. I have made so many different file formats. It was MKT-PIC, MKT-AG. By the way, it's... How did the image one work? It was... I don't remember, but I remember it had compression, which was really cool. Hold on. Let's go back to the engine for a second. It was in file libraries, pick to raw to pick. There we go. This is how it worked. Although, is this the compressed one? Oh, I forgot I did that. Oh, I forgot I did that. So... Oh, I forgot I did that. Okay, well... Oh, wow. Oh, I forgot how much fun I used to have in the sea. It's like an... I've seen visual OS. Like, y'all are making OS for everywhere nowadays. I wanted to make my own operating system, but it was difficult and I didn't have the time to deal with Linux. He's not getting any work done. I might be, as I mentioned, I'm rendering in the background, so I really have nothing better to do anyway. But I just forgot how much fun I used to have. I mean, look at this code. It's beautiful. It's really beautiful. As a C++ programmer, I appreciate that. You mean this? I mean, I'm guessing that's what you mean, right? Unless that's not what you mean. Because there is a lot of pointers for C++, honestly. Like, for a C++ programmer, that is already an excessive amount of pointers. If the code works, it works. What do you mean if the code works, it works? This is elegant. Cole, listen. You don't get it. You just don't get it. You just don't get the... Okay, look at this, okay? Look at this right here. Okay, actually, this is pretty simple. This is really simple, in fact. Oh yeah, I also had MKT RGB AP, which was my own value for colors, of course. I'm learning French. Why? You? Not about the size of the code, about the friends we made along the way. The true C programming was the friends we made along the way. Also, this is phenomenal. That's because... Oh yeah, I completely forgot. Oh my goodness. In this code, actually, fun fact for everyone, when it comes to this code, I'm pretty certain the size of the image... Oh my goodness, like the size of the image was always... I mean, the image was always a rectangle, but you could have saved it so in a way so that when it was loaded in, it would have a different shape. So the size of the image was a rectangle, like in every other image, but the engine would load it in as a custom shape depending on how you defined it right here. It obviously had to only have 4 vertices. This was hard-coded because this was all work in progress. Can't read the code, font is too small. There we go. I really like this for loop, honestly. This is a banger for loop. This is such a make it for loop. I love it. Learning French of your own free will. No one. My own free will. Why? No. Why? No way. How'd you call that? Actually, it's pretty easy. Mostly based on how Vulkan works. Like, when it comes to Vulkan, whenever you load an image, it's... If I remember correctly, I did that like 3 years ago, okay? So, take this with a grain of salt. But if I remember correctly, when it comes to loading an image, you're basically loading it onto... I don't know what are they called. Well, let's just call it shape for now. You're loading it onto the shape, and then you're kind of mapping it. That's not a great explanation. Use ChatGPT on the side, I swear. When I coded this, ChatGPT wasn't even a thing. Back in my old days, when I coded this, ChatGPT didn't even exist. Yo, read other side's comment. Other side retracted his comment. But honestly, I don't know. You compare these over 25. What do you mean? Use AI to write anything that's HTML. I guess that's fair when it comes to HTML. When people really often like to point out how, you know, AIs can code and such, they never give them any difficult things to do. They always give them the easy stuff. Like, for example, this. ChatGPT could understand what this means, but ChatGPT wouldn't produce it. Not really because it's difficult, only because it's a complex thing. And ChatGPT, as a, you know, like it mostly takes like an, you know what, I'll save it for the AI's video. I'll make an AI's video soon. Anyhow, material science, everyone. Time to get in, right? AI basically screws anybody who is average. I mean, AI produces average stuff. That kind of by definition. Or decide you're deleting messages way too quickly. One of my friends used ChatGPT to make a full web game launcher. Yeah, but, you know, making a... What do you mean by a web game launcher? That's a good question. Because if you mean he used ChatGPT so that he wouldn't have to write boilerplate, then that's just... Yeah, I mean... Yeah. AI can do easy stuff, but it sucks a lot of stuff that involves math inside the code. Not even math, but just anything difficult. GPT couldn't first have because 1, no reference tag of 2 safety. When it comes to the full web game launcher, I'm not really impressed because what I'm guessing happened is WebGL. What I'm guessing is ChatGPT just wrote for your friend boilerplate for WebGL, PHP, and all the backend. That's not. Once again, depends what you mean by a launcher. Because if you mean like graphical engine, then what I'm guessing happened is ChatGPT just wrote boilerplate for WebGL, which is not difficult. I can just Google that. Boilerplate for WebGL. I've never coded in WebGL, but I'm assuming there's boilerplate. Wow, there's even a whole website for it. Gotta love me some. That's JavaScript. Or I have no idea. I'm not a web developer. No. It's var. Yeah, PHP uses $signs. I tried to make ChatGPT optimize something for hours and didn't understand. Why is that table so aggressive? Wrong, 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 wrong. Oh wait, yeah, we didn't get into textbook at all, did we? It's because it's a silly model, that's why. There was a case when AI refused to show C++ solution to an underage kid because it took unsafe, literally. Okay. Are we getting into it? I feel like we've already exhausted all of our usual, you know, beginning live stream complaints. And let's get into why this is wrong, 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 wrong. And all the other stuff. So let's answer the question, why don't electrons fall into the nucleus? That's an interesting question, right? They're orbiting it, not falling in, which is weird. Shouldn't they fall in? That's a grand question and we'll answer it right now. Let's see. The picture of electrons orbiting the nucleus like planets around the sun remains an enduring one. Not only in popular images of an atom, but in the minds of many of us who know better. I don't really get the idea of being aggressive about this model, because, I mean, yeah, it is inaccurate. Force. Nice picture, but simply untenable. Yeah, this might be a bit broken, because I'm using dark mode. So these graphics might be a bit screwed up a bit, so slightly. That's on me. I'm really sorry about that. Okay. One origin for this hypothesis that suggests this perspective is plausible is the similarity of the gravity and Coulombic interactions. The expression force of gravity being two masses, Newton's law of gravity, with some rate of separation. Okay, so basically force of gravity is proportional to the first mass, second mass, and distance squared. Many of your Morse geeks maybe. What do you mean? What do the geeks do? Poor geeks. The expression the Coulomb force between two charged particles, read expression. Yeah, so many of you probably are familiar with although I think they use M1 and M2 for force of gravity. And that's why it's proportional, because instead of noting down a variable, you could just do drop to. There we go. You can just note down like this. This is fascinating. Does streaming decrease your reading comprehension, or do you remain unaffected? When I don't stream, I act the exact same way. When I don't stream and I'm learning about something, I'm just talking to myself. So I don't know. I don't have like a control group to test this theory. Like it might, but since I always act this way, there's no way I would know. He's antisocial. Am I at this point? I don't. That actually sounds quite like the opposite of antisocial. That sounds like over social, if anything. It's the universe company never changes. Yeah, I'm always the same. No, electrical charge. Okay, quantum theory, the rescue. By 1920s, it became clear that a tiny object such as an electron cannot be treated as a classical particle having a definite position and velocity. The best we can do is specify the probability of its manifesting itself at any point in space. If you've seen my quantum mechanics live streams, then this is just Psi, the freaking big ol' lovely capital Psi in a nutshell. If you had a magic camera, and I do have a couple, that could take a sequence of pictures of the electron in the first orbital of a hydrogen atom, you could combine the resulting dots in a single image, you would see something like this. Clearly, the electron is more likely to be found closer moved to a nucleus. Yeah, so it's basically more like probability than a result position. I love, by the way, how the second I started going to textbook, the viewership just halved itself. Half of the people left. Most of y'all just joined in for the chit chats. Honestly, I can't even blame you. So I would like to. Yeah, I would like to raise a glass. I know you can't see me right now, but I'm raising a glass to all of you who endured. You're still with me. Cheers. Ah, I joined for chits. I just like the smell of you. Well, that's creepy. Boy, is that creepy. And although I do have a pretty nice scent, I smell of motor oil. Hold on. This is probably plot, short quality. Okay. As you know, oh, we're getting into infinities. That's interesting. That's such a waste. I can't tell if you're British or if you're just making up words. What's the difference, to be fair, actually? As you know, the potential energy of an electron becomes more negative as it moves toward the attractive field of the nucleus. In fact, the produces negative infinity. However, because though energy remains constant, a hydrogen atom sitting peacefully by itself will never lose nor acquire energy, unprecedented as even a law. The loss in potential energy is compensated by an increase in the electron's kinetic energy, sometimes referred to in this context as confinement energy, which determines its momentum and its effective velocity. So the closer it is, the higher the kinetic, the lower the potential. Makes sense. So the closer it is, the more of the potential energy gets exchanged for the kinetic energy, which once again makes sense. So as the electron approaches this tiny volume of space occupied by the nucleus, its potential energy dives down towards minus infinity, and kinetic energy, momentum and velocity, shoots up towards positive infinity. This battle of infinities cannot be won by either side, so a compromise is reached in which theory tells us that Fall in potential energy is just twice the kinetic energy, and the electron dances at the average distance that corresponds to Bohr radius. Okay, makes sense. The difference between you and Kurzgesagt videos? Kurzgesagt have like a lot more people. The fact they do stuff fun for everyone. Ouch, mean. Shots fired. Does Heisenberg's uncertainty principle apply to electrons? Yes. Heisenberg's uncertainty principle. I'm pretty certain it applies to everything, actually. Because it's because Heisenberg's uncertainty principle, I think it's derived from, we've been researching this for quite a while. It's derived from wave behavior. It's more derived from wave behavior than the particles themselves. And I'm pretty certain that electrons still behave like waves. So trying to pinpoint the location of them electrons satisfies knowledge of their vector. It's... Okay, the principle works like this. Hold on, let me bring on my paint. Or actually, you know what? I don't have to. I can just put it into words. Basically, when it comes to waves, you can't know the position. It's a relation between knowing the position and frequency of a wave. And so the position of the electron would mean its position. And the frequency, in this case, could mean its kinetic energy. And kinetic energy means momentum. So, Heisenberg's uncertainty principle applies more to waves than to particles themselves. It's just that particles use those waves, kind of. So, frequency, you can't know at the same time perfectly frequency and position of a wave. That's the basic idea. And then, because this translates to position or kinetic energy, so momentum and all the other stuff. Aren't we all standing waves according to string theory? I haven't researched string theory yet. Yo, teach me as my tutor for the SHSAT. What's SHSAT? Also, you're being really mean to me right now, you know that. SHSAT, specialized high school admission test. Ooh, 20% acceptance rate. Damn, that's strict. From 25,000, that's really strict. I'm uncertain about the uncertainty. Well, that's the, I like to call it the meta Heisenberg principle. So this is basically how people can't at the same time understand the Heisenberg's uncertainty principle and not be a nerd. Boom. Shots fired. Oh wait, there is still one thing wrong with this picture. According to Heisenberg's uncertainty principle, speak of the devil and they shall appear. A better term would be indeterminacy, as a particle as tiny as the electron cannot be regarded as having either a definite location or momentum. That's what we've been talking about. I should really read that. A particle was saying, yep, the Heisenberg uncertainty principle says that either the location or momentum of quantum particles such as electron can be known as precisely as desired, but as one of these quantities is specified more precisely, the value of the other one becomes increasingly indeterminate. It is important to understand that this is not simply a matter of observational difficulty, but rather a fundamental property of nature, or fundamental property of waves, which I guess fundamental property of nature. Alright. I would know. I did write this textbook course. Ah, I see. Dang it, Steven. Probability density versus radial probability. Okay, let's go forward. This is, I'm pretty this is the last subchapter, right? We can, however, talk about where the electron has the highest probability of manifesting itself. That is, where the maximum negative charge will be found. Probability density. Okay, so peak radial probability principal number and one Bohr radius. So that's why it isn't going in. That's why it's maintaining this distance, or rather, its probability of finding it is the highest on that distance. Okay. Properties of gases. Oh, we're getting the chemistry stuff. Finally, we're done with quantum. Oh, goody. Only 4. That's really short. Let's go for it then. Does no one memorize the name of stars here? What? Sir, this is Wendy's. I mean, sir, this is a chemistry research. This picture. Alright. The study of gases allows us to understand the behavior of matter at its simplest, individual particles acting independently, almost completely uncomplicated by interactions and interferences between each other. This knowledge of gases will serve as a pathway to our understanding of the far more complicated condensed phases, liquids and solids. Hold on, the music just stopped. And there we go. Sometimes probability feels like researchers coping with universe pesky complexity. It does feel like it sometimes, but there are fair reasons. They have their reasons. And I guess. Application liquid interchanges between each other. This knowledge of gases will serve as a pathway to understanding of the far more complicated condensed phases, liquids and solids, in which theory of gases will no longer give us correct answers, but will still provide us with a useful model that will at least help us rationalize the behavior of these more complicated states of matter. Okay, so we first, when it comes to matter, we first begin with gases. There we go. Will you ever do another politics video? Yes, I will. That's the answer. I'm gonna end it there. We'll need to do a lot of research for that video though, because I am not the kind of person that likes to talk about like subjective things. Like, you know how you have positive macroeconomics and restrictive? No wait, it was something. And the other kind of macroeconomics. Like one talks about objective reality and the other talks about whenever something is good or bad. Make it attempting to be Girage. Oh, I would love to be Garage. I would love to be, really. I love Giraffe. Alright. First, we know that a gas has no definite volume or shape. Gas will fill whenever volume is available to it. Contrast this to behavior of a liquid, which always has a distinct surface when its volume is less than that of the space it occupies. The other outstanding characteristic of gas is their low densities. Compared with those of liquids or solids, 1 mole of liquid water at 198 Kelvin and 1 atmosphere pressure occupies a volume of 18.8 centimeters cubed, whereas the same quantity of water vapor at the same temperature and pressure has a volume of 30 decimeters cubed? 30 decimeters cubed, I'm pretty certain. More than 1,000 times greater. Wait, make it. Is garage two sides of the same coin? We really are. We're. Wow, I basically start my every day. You know what? Every single day when I wake up, first thing I do is just open Garage YouTube channel and just yell at the top of my lungs. He's literally me. He's literally me for real. That is how I start my day. Okay. The most remarkable property of gases, however, is that to a very good approximation, they all behave the same way in response to changes in temperature and pressure, expanding and contracting by predictable amounts. This is very different from the behavior of liquids and solids, in which the properties of each particular substance must be determined individually. We will see later on that each of these three macroscopic characteristics of gases falls directly from a microscopic view, that is, from atomic nature of matter. Cool. Pressure of gas. This is surprisingly short, actually. Did I mention already how much I love this textbook? I feel like I only mentioned it 7 times. Alright. The molecules of gas being in continuous motion. Okay, let's try it again. The molecules of a gas being in continuous motion frequently strike the inner walls of the container. As they do so, they immediately bounce off without loss of kinetic energy, but in reversal of direction. So they just, physics. It's kind of like if you were to throw some balls into a container. Same thing. No difference. This force, divided by the total surface area on which it acts, is the pressure of gas. Makes sense. Your Canadian accent is showing. My Canadian accent. You know me, my Canadian accent. Downward force to gravity acting in piston area, movable piston, friction weightless. When piston is stationary, the pressure of gas P is the pressure created by force. Yeah, that's the definition of pressure, basically. Where am I pulling from? I don't know. Big science guy, eh? We're learning some science, eh? That's all I know about the Canadian accent, though. The A. That's all there is, no A. Canadians have an accent? I only recently learned they were real. I thought y'all were just joshing around. I thought you all were playing me for a fiddle. Wouldn't aboard an average most of gases? Average most of gases? Aboard? Your bags of milk, honestly. The silly Canadians. Wait, isn't Quant from Canada? like we just had a serious conversation about this last live stream about how like Canada is becoming world power because they have water, and how we should stop global warming just so that Canada wouldn't get any more power. Like, stop global warming is decent, of course, but stop Canadians, that's better. The pressure of a gas is observed by measuring the pressure that must be applied externally in order to keep gas from expanding or contracting. To visualize this, imagine some gas trapped in a cylinder having one enclosed by three moving pistons. Okay, so there's the example above, right? Push it out. The pressure of the gas is simply the quotient force divided by area, where area is the cross-section area of the piston. So yeah, just pressure. Of pressure is Pascal. Defines a force of 1 Newton per square meter. So yeah, just pressure. We know all about them. Pressures. Wooden aboard. Wait, hold on. Am I going crazy? By the way, we've just dropped to 3 viewers. Right now. Oh, wow. Okay, so we've dropped. Have you researched Monix? Mention of velocity, pace system, Dominic system, and so on? No. No. I don't know any Monix or anything. Hold on. You mean to tell me that from the moment we were just chit-chatting to now, we've already dropped 3-fold? Well, that's great. Alright. Fine, whatever. I'm fine. I'm great. Price of being a nerd! Ah, oh, damn it, you're right. I'm still here. Thank you, Noel. You're a real trooper, I gotta say. If several kills were constantly pressing down body, why do you not feel it? Solution, because every part of your body, yeah. So basically pressure. Casual step. This is just history, right? Yeah, okay, this is just history. Classical barometer, still used for most accurate work. Measures the height of a column of liquid that can be supported by the atmosphere. Statically, the liquid... Okay, yes, this makes sense. I joined Quant! Oh, we're just talking about you. As a background noise while I do my algebra homework. That's what most people use my live streams for, and you know what? That's a fair deal. I'd say that's a completely fair way to use my live streams. Metallic mercury, being a liquid of exceptionally high density and low vapor pressure, is the ideal barometric fluid. Its widespread use gave rise to millimeter of mercury, now it is referred to as TOR, measure of pressure. That's another one of freedom units, isn't it? Got a clickbait. You won't believe how temperature relates to pressure. No, I won't. I refuse. I don't want a clickbait. I know so many people are telling me I should click my videos. And I know. I want to. That's not who I want to be. A modification of the barometer, the YouTube manometer, provides a simple device for measuring the pressure of any gas in the container. The YouTube is partially filled with mercury. One end is connected to the container, while the other end can either be open to the atmosphere. Pressure inside the container is found different. Okay, so this is a manometer. This is just mostly history. Christian, why were you just talking about me? Oh, Canada stuff, you know how it is. Please maintain your intellectual integrity. It's your third best quality. Wow, that's, I like you, Andy. Don't worry, I will. I refuse to clickbait stuff. Someone just pointed out to me, like... We recently had a chat about this on Discord too. How actually bizarre it is. You can see how weird my titles are. Like, they are so mundane. For example, most people on YouTube, I don't know why exactly, but they capitalize every single word. I guess to make their videos more stand out. It's something I don't just do. Like, I get why this video only has 1,000 views. I completely understand. What's my second most popular video? Still electric versus electronic? By the way, this video has 300,000 views, okay? 300,000. My entire channel has 400,000. You would get so many more views if what is the worst mistake humanity could ever make was how AI will kill humanity in the next 10 years. Yeah, I know, but I don't care. I don't want that kind of views. I don't want the blood money. I don't care. You should make it all lowercase. I'm not a capitalist, so all of my letters are... I never capitalize my letters. I'm a socialist. Comrade. The molar volume of gas. You will recall the molar mass... okay, so molar volume is just the volume per mole. Yeah, once again, moles. We get how this works. Estimate the average distance between the molecules in a gas at 1 atmospheric pressure and 0 degrees Celsius. That's a good one. Average distance. What's the watch rate in the vid? First 2 minutes and last 5 minutes. What video? You need to be more evil. I refuse. I shan't let the forces of the dark corrupt me. Can you please shout communist slogans in Polish for the 5 of us that have stayed here? Cool request. Soft pass for now. I don't know, if Quant were to ask me that, I would say yes, because Quant is Patreon. But but soft pass for now. I would say yes to Quant, because Quant is a patron, and for some reason I just find the idea of, you know, counting communist slogans for money, I just find that comical. Yeah, okay, hold on. What were we talking about? OnlyFans idea. Hold on, what were we talking about? Oh yeah, right. The volume per molecule. So yeah, this is just standard mole stuff, right? Just per molecule. The composition of a gas mixture. Okay, finally getting somewhere. Because most of the volume occupied by gas constricts in space, there is nothing to prevent 2 or more kinds of gases from occupying the same volume. Homogeneous mixtures of this kind are generally known as solutions, but it is customary to refer to them simply as gaseous mixtures. We can specify the composition of gas mixtures in many different ways, but the most common ones are by volumes and mole fractions. Ideological prostitution. I don't know if it's a new kind. It's not what capitalism is. Or communism, I guess. Where like people just sell out their morals for power and money. My original idea. Can you please shout communist slogans in Polish for the 5 of us that stayed here? Quant, I would love to, okay? Anything for you, Quant. What kind of... Wait, I don't know any communist slogans though. I don't know any ideas for some slogans, because I don't know any actually. Sugar daddy now asked. What slogans should I ask? I could just I don't know, translate things to Polish if you'll want, and we can just pretend that these are communist slogans. Down with the bourgeoisie. Oh wait, what would be the bourgeoisie? Fuck, what's bourgeoisie in Polish? I don't know. Wait, what's bourgeoisie in Polish? Is bourgeoisie even a English word actually? Translator. Polish. Hold on. Okay, maybe the text language first, because... No, it's English. Okay, well, that's a... Is it English? Hold on. I don't think it's English. I think it sounds French. Something I don't know, cool. So he was born after the fall of the USSR. Down with Big Brother, probably. I don't know. I finished it recently. Oh, how was it? Should stop dropping batteries everywhere. Sorry about that. Sorry about the noise in the background. How was it? Bourgeoisie is French bourgeois. Yeah, I don't know there's no translation apparently. Seize the means. Oh, that's a good one. But hold on, let me just seize the means production. I'm too lazy to translate myself. Zgarnąć środki produkcji. There is no way that's how it. There is no way. Równość dla wszystkich. Zgarnąć środki produkcji. Wszyscy musimy się zjednoczyć i walczyć o nasze prawa. There. Is that something? If you'd like to get more, I'm gonna upload Patreon only. Patreon only make it yelling communist slogans in Polish video. Also, maybe you type bourgeoisie correctly, which you get the result. Yeah, but you know, I'm not here to type in stuff correctly. Bourgeoisie. Hold on. Them rich fucks. Class. What were they called? Bourgeoisie. Okay, I don't like the results there. Okay, so previous results weren't fun. Bourgeoisie. Is that how it's... Oh, them. Oh, yeah, you're like a redneck French, right? I mean... Canadian. Bourgeoisie. Fuck, that's dumb. That's such a dumb way to translate it. I love it. Most recent comment from additional context visit. Most recent. Alright, let's see. Where's he? What a translation, indeed. Videos. Oh wow, this Make It Fella is live! And there are 6 people watching, isn't that crazy? How do you solve by newest first? Get down to business. This one, arbitrary code executions. Fun fact, our French more resembles 1800s French. Huh. So basically speaking old French. So French are the true redneck French. Right? I don't know what's the definition. Make it makes mistakes. Oh yeah, this is about the age. Hold on, I would need to watch that segment of the video. Because this is about the derivative segment, so this slope. The issue is, but okay, this is actually pretty funny because I explained, the point of this video was to explain advanced math without using advanced math. And and so something which people actually pointed out from the very beginning is that I basically explained derivatives without using limits. I don't know if any of you noticed in the video, but there isn't a single limit in the entire video. I explained calculus without a single limit. Okay? Which is... well, let's just say I'm kind of happy with that. Up. There we go. And this basically comment is precisely about that I can't use, that I didn't use a limit. But that's kind of... it's not really a bug, it's a feature, I would say. Moment. In English rostrum constant. It's like putting a boy on hair. What now? New calculus? What's new calculus? I'm still in algebra 2, what's the limit? It's... limit is like when you want to use a value but can't. That's the limit. Like, imagine if you wanted to input 2 into your equation but you can't. Then you just do a limit. Epic explanation. Basically edging. Actually, you know what? Yeah, it actually is. It's mathematical edging. That's precisely what... you know what? That's a phenomenal answer. That's precisely what the limit is. Yeah, like, imagine if you wanted to use a value, but you almost use a value. Like, imagine if you... okay, if you will, imagine... let me bring up my paint. So basically, imagine that you have a function, right? And into this function, you want to function of x, right? And into this function, you want to check what the function would be equal to when you input 2 into it, all right? That's what you want to find out. But the issue is that your function, right, would look something like 2 minus x, and at the top you would have I don't know, just 3, I guess. That's good enough. And so the issue is that that's not a good example. Good enough. The issue is that you can't really input 2 into this equation, because then you get 3 divided by 2 minus 2, which is equal to 3 divided by 0. And 3 divided by 0, well, that's a no bad south base, basically. And so instead what you do is you edge yourself. So you basically do a limit of x as h approaches 2 of f of h. And so then you don't really do this, only you basically, if you have a graph, wait, what would this function look like actually? It's basically 3 divided by x, except moved 2 units to the right. So this is what this function would look like. So right here you have 2. So instead of inputting 2, you basically ask yourself, what does this value approach as you get closer and closer to 2? And you can see that if you approach from the right, you get to positive infinity, and as you approach from the left, you get to negative infinity, and yeah, you just keep on going. I'm gonna tell that to my teacher. My teacher loves edging. Cool. Wow, we're actually back to our original viewership. Oh no, we're not. Never mind. Back to 6. How do you graph down funnels without the math to find the isomers and all that stuff? It's easy actually. It's not that hard. Wait, let me see first if I was correct. How about that? It's not that hard. Intuition stuff. No, it's actually not. You can just move functions around if you want. Like, basically, I can switch this to A, and then you can see that this is just moving the function. I thought about making a video about how to modify functions this way. Or for example, I could do... That will be another good example. Like, for example, if we have x squared, right? This function looks like this. But we have x minus a squared, then we can also move it around. Might you give me like an 8-part equation to that? Wait, do what? I mean, figuring out what divided by 0 is equal to, or just figure out how to get a certain equation. I usually use derivatives to find out what equations I'm looking for. Like, I remember one time I needed a very specific function, and for some reason, which looked like this. And so basically my train of thought was, okay, so the slope is going down and down and down the further we go. And it's going at an exponential rate, which means this equation would be the integral of 1 divided by x dx. So from 0 to x actually, and this should be a. Oh yeah, because a is already used. C when as well. Right. And then it's broken because of course this. I don't really care enough to fix it. Desmos, my beloved. Desmos is great. Check charity checkup general on Discord. Oh no, what'd you send? Hold on. It's a clip. Edge yourself. Hold on, let me pause the music first. That's a no bad sad face basically. And so instead what you do is you edge yourself. That's a perfect description. What about edging f of x equal to x squared plus x divided by x? Oh, are we really gonna edge it? I mean, I guess we can. Hold on, wait, isn't this something you can solve actually? I may be wrong. I am probably. F of x is equal to... Wait, this is easy, isn't it? Am I... No, this is easy. Hold on. X squared plus x divided by x. Whole linear function. Wait, but this is easy, right? Can we just... Am I missing something? You don't really need a limit for it. I mean, yeah. But yeah, but that's the basic idea. And that's kind of actually the heart of calculus, in my personal opinion, is finding ways to avoid dividing by zero by realizing, like for example, in this case, right? If we input 0 into this equation, we would get 0 squared plus 0 divided by 0, or in other words, we would get 0 divided by 0, which is technically, like kind of, not technically, only kind of infinity times 0, which is the greatest sin you could ever commit. And so that's kind of what calculus is about. Instead of getting into this situation where it's basically a big no-no problem, you can just, you know, solve it. And this is 0, obviously. Then this is equal to 1. Which functions need holes again? I don't know. No, I'm not a subscriber of math. Not anymore. I'm done with my math arc. We're now moving into my physics arc. I'm trying to avoid... I really like that. That's a good one. Alright. Expressing the composition of gas mixture. Because most of the volume occupied by a gas constricts of empty space, there is nothing to prevent two or more gases... Oh yeah, wait, we've already been over this, right? Volume fractions. From Avogadro's law, we know that equal volumes contain equal numbers of molecules. This means that the volume of gases, unlike those of solid liquids, are additive. So if mentioned container has two volumes of gas A in one section and 1 mole of gas B in the other, both the same temperature and pressure, and we remove the partition, the volume remains unchanged. Makes sense, I'd say. I can't believe I missed your math arc. No, you didn't. It's just ending right now. You've been here before. Just during these live streams, we're just slowly but surely transitioning from my math arc into my physics arc. And then from that we'll transition to my chemistry arc, then medicine arc and electronics arc. And then I'll basically turn my entire body into a droid with, you know, implants. Let PDFs put in Checkup's channel on Discord. That's what my teacher had me do. Wait, hold on. Let's see. Can I show it on stream? Yes, okay. Wow, that's it very well maintained. Graphing rational functions, okay. Where P points, okay, can't contain vertical symptoms. Horizontal have X and Y. That's a lot of information. The key features. Okay, so this one I'm guessing. So we have sketched the graph and identify the key features. The vertical asymptote. Oh, these are the things. Oh, wow. Yeah, so vertical, horizontal asymptote, sign chart. But these still are kind of useful every now and then. It's just that Yeah, I get what you mean. But you don't need to... I mean, these are sometimes useful when you want to create an exact graph. It's just that... and if you're dealing with more complex functions, actually. For the basic ones... When you're dealing with more complex functions, this might be a better way to do it. It's just that for the easy ones, you can just do it in your head. Don't let this type of notation put you off. Summation sign in Greek simply means add up. I love this, by the way. I love that every single time we encounter a sigma, it's basically, don't worry, it's just addition. Because that's basically what I've been saying every single time I use sigma in one of my videos. What's the best way to learn new concepts, Maki? I should have called me Maki. Oh, I love it. No one calls me Maki. You all just call me Make It. So formal. Take your shoes off. We're not. It's not a business meeting. Maki. I've never seen anyone refer to me with Maki spelled like this. Best way to learn new concepts? I don't know. I don't know if I'm the best authority on it because I just go in all the way. Like, for example, when I started learning programming, the first project was the Ventum engine, which then stretched over to multiple years. So, you know, Maki, I like that. I like that a lot. Means to add up B's volumes of every gas. Thus, if gas A is the ith substance, as in the expression immediately above, the summation runs from I is equal to 1 through I is equal to 2. Yeah, we know how summation works, okay. Dalton's law of pressures. That seems fun and new. Project-based learning is best. It really is. The ideal gas equation of state applies to mixtures just as pure gases. It was in fact with a gas mixture, ordinary air that boil... Hold on. Low density and high compressibility of gases indicates they occupy mostly of empty space. From this, it follows that two or more different gases occupy the same volume. They behave entirely independently. Okay. Contribution that each component of gas mixture makes the total pressure of the gas is also known as partial pressure. Okay, so it's basically a sum of all pressures. So if we have air, right, like good old-fashioned air, then we can, the pressure would be equal to the pressure of oxygen plus the pressure of nitrogen plus the pressure of carbon dioxide plus the pressure of all of them. Can you do a project as an entirely foreign concept, as abstract algebra or linear algebra, or do you do a project after as you learn? In which case you need to break the individual concept. So, that's a tough one. Depends. If I need to learn something, as in if someone is forcing me to learn something, then I first try to study it as much as I can, and then I do the project. If I'm learning something all by myself, then I just do the project, and then learn whilst doing this project. That's because when I'm doing something by myself, I usually am learning stuff in order to complete that project. You just make it. Precisely. I just make it happen. Honestly, I only have one piece of advice, and that's disrespect the study. That's my only piece of advice. So pretend that whatever you're trying to learn isn't difficult, even if it is. Because if you pretend that it's not difficult, then it becomes much easier to approach. So that's, for example, how I learned about quantum mechanics, right? I was just pretending that it's not difficult, and then once I actually learned the basic, I was like, oh, that really isn't difficult. That's actually pretty easy. And then I made a video, and I earned millions of dollars, and, you know, became rich and famous. Disrespect the study. Amazing. Yeah, don't disrespect the science, but disrespect the study. Just gaslighting yourself. Yeah, always works. Denial is always the answer. Alright. Application of Dalton's law, scuba diving. Our respiratory system is designed to maintain the proper oxygen concentration in the blood when the partial pressure of oxygen is 0.21 atmosphere. Its normal sea level value. Below the water surface, the pressure increases by 1 atmosphere for each 10 meters, increasing depth. Thus, a scuba diver at 10 meters experiences a total of 2 atmospheric pressure pressing on the body. In order to prevent the lungs from collapsing, the air the diver breathes should also be about the same pressure. But in total pressure of 2 atmospheres, the partial pressure of oxygen in all the ordinary air would be 42 atmospheres, and depth of 100 feet, about 30 meters, would be 08. For this reason, the air mixture in the pressurized tanks that scuba divers wear must contain a smaller fraction of oxygen. Achieved most simply by raising the nitrogen content, but high partial pressure of nitrogen can also be dangerous, resulting in a condition known as nitrogen narcosis. The preferred diluting agent for sustained diving is helium, which has very little tendency to dissolve in the blood even at high pressures, I'm guessing because of the whole noble thing. That's really cool. That is really cool, I like that. That's actually golden advice. My math teacher introduced differential equation to my class, they didn't know it, as something casual and easy and amazing. They all learned it much faster than I managed alone. Yeah, I just disrespect the study. My only advice. That's how I learned. Calculus, that's how, well, kind of learned calculus, I guess. I know. I never bothered to do the actual equations because calculus, when it was to calculus, I was just studying it by myself, self-taught. And there was no actual benefit to solving the equations, and it was a lot of work. And I don't regret it, honestly. I mean, I could still learn how to solve all of these equations, but there's no point. I'm not a specialist. If I wanted to become a mathematician, then yeah, that would be useful. But knowing the concept is good enough for me. Alright. How long have we been streaming? Hour and a half. We're already going crazy. How are the animations doing? Hold on, one of them needs one more frame, which I forgot to add. There we go. What was the highest math in high school? I don't remember. I really don't remember. I can tell you the highest math. I can tell you the most complex thing I remember learning in high school. I wasn't paying that much attention, not gonna lie. I really am not the kind of guy who just studying this way. So I can tell you the most advanced topic I remember learning in high school. Goes to math, and that is I think trigonometry. So yeah, not at all advanced. I mentioned I wasn't really paying attention. I prefer studying for myself. %33% of the votes, chemistry. My custom project was summing 2 and 2, took most of the semester. It was make it simping over girls. There was, you know, Ryan Gosling. Do I really seem like the kind of guy who wants to be in a relationship? Especially with girls, ew. The kinetic molecular theory of gases may sound rather imposing, but it's based on a series of easily answered assumptions that, taken all together, consider model that greatly simplifies our understanding of the gas state of matter. 5 basic tenets of kinetic molecular theory as follows. Okay, we should note this down. Them's laws. It's in my textbook. Grezmaki. Sitting in the tree. No, I would no. I mean, maybe, you know, if Gyrish would want it, maybe who am I to say? I mean, you know, that would be pretty rude of me to say no, right? I mean, if Gyrish asked me, then I don't know. Well, seems pretty rude. I'm just saying, okay? Hold on. We're learning about the kinetic molecule theory. Gases compose of molecules that are separated by average distance that are much greater than the size of molecules themselves. The volume occupied by molecules of the gas is negligible compared to the volume of the gas itself. Okay. The volume occupied. Yeah, I'll mostly copy paste these laws because as much as I don't like copying pasting, when it comes to laws like these, putting my own spin on it might not be a good idea. By the molecules of the gas is negligible compared to the volume of the gas itself. Makes sense. Most of it's empty space. Makes sense. The molecules of an ideal gas exert no attractive forces on each other or on the walls of a container. Okay. No attractive forces on each other or on the walls of the container. 3. The molecules are in constant random motion, and as material bodies, they obey Newton's law of motion. This means that the molecules move in straight lines until they collide with... okay, so just... the molecules are in constant random motion, and that's enough. Collisions are perfectly elastic. When two molecules collide, they change their directions and kinetic energies, but it's all kinetic energy is conserved. Collisions are not sticky. Once again, makes sense. So, collisions are perfectly elastic. And then the 5th one. Average kinetic energy of gas molecules directly proportional to the absolute temperature. That's, yeah, okay, once again, obvious. Any questions about these laws, by the way? Anyone curious? Something doesn't make sense or something? You can zoom in if you want, by the way. There we go. Anything? Quit using Polish. Just quit it. Quit that. Hold on. There we go. Damn, my dummy hat is in the way. According to this model, most of the volume occupied by a gas is empty space. This is the main feature that distinguishes gases from condensed states of matter. Makes sense. In which neighboring molecule... I keep saying makes sense. Should really come up with something more clever to say. According to contact, gas molecules are in rapid and continuous motion. Ordinary temperatures and pressures, their velocities are in order of from 100 to 1 kilometer per second, which is crazy quick. Crazy quick. That's 3,600 up to 3,000 kilometers per hour, which is insanity. And each molecule experiences approximately 10 to the 10th collisions with other molecule every second. Okay. Gas molecules at ordinary temperatures, pressures have velocities of order 0.1 to 1 kilometer per second, which is insane, and experience around 10 to the 10th collisions each second. These numbers are insane. Gas laws explained. If gases do in fact consist of widely separated particles, then the observable properties of gases might be explainable in terms of the simple mechanics that govern the motion of the individual molecules. The kinetic molecule theory makes it easy to see why a gas should exert pressure on the walls of a container. Any surface in contact with the gas is constantly bombarded by the molecules. And that's why we can also neglect, and that's why also abstraction works so well, because the velocities are so great and the amount of collisions is so great that taking an average will not change the result all that much. So for example, when you're dropping balls, right, onto like a sheet of metal, then having a model which represents these balls as pressure, right, the forces that these balls exert on the sheet as pressure would be inaccurate. But if you have particles which collide this often at these velocities, then it becomes really accurate because of just how often this happens. The average temperature of the universe goes to 0 Kelvin. Wait, how can... I mean, okay, that makes sense. For a second my brain was like, what do you mean 0? But yeah, okay, it makes sense. Second, my brain interpreted it as, you know, the temperature of the universe could be rounded to 0 Kelvin, which I know why. I don't know, my brain bizarre. I should get a new one. At each collision, a molecule moving with momentum mv strikes the surface. Since the collisions are elastic, the molecule bounces back with the same velocity in the opposite direction. This change of velocity, delta v, is equivalent to an acceleration a according to Newton's second law. A force F was equal to ma, and is thus exerted on the surface of area A, exerting pressure of P is equal to Fa. Okay, kinetic interpretation of temperature. According to kinetic molecular theory, the average kinetic energy of an ideal gas is directly proportional to the absolute temperature. Kinetic energy is the energy of a body as a virtue of its motion. Quit it, Andy. You're bringing back bad memories. As the temperature of a gas rises, the average velocity of the molecules will increase. A doubling of the temperature will increase this velocity by a factor of 4. Because square. Collisions with the walls of the container will transfer more momentum and thus more kinetic energy to the walls. If the walls are cooler than the gas, they get warmer, returning less kinetic energy to the gas and causing it to cool until thermal equilibrium is reached. Because temperature depends on the average kinetic energy, the concept of temperature only applies to a statistically meaningful sample of molecules. We will have more to say about molecular velocities and kinetic energies further on. So once again, this model makes sense. Do you have negative association of Polish being used in chat? I know, I have negative associations of Polish. And, just Polish. Why? Maybe just joins in, tries to act like my psychotherapist. Come on, mate. What makes you feel this way? How do you feel? As the temperature of the gas rises, the average velocity... Okay, yeah, we've been over this. So, kinetic explanation of Boyle's law. Boyle's law is easily explained by kinetic molecular theory. The pressure of a gas depends on the number of times per second that molecules strike the surface of the container. If we compress the gas to a smaller volume, the same number of molecules are now acting against smaller surface area. So, the number striking per unit of area, and thus the pressure is now greater. Yes. Kinetic explanation of Charles' law. Oh wow, we're just going over laws, that's great. Kinetic molecular theory states that an increase in temperature raises the average kinetic energy of the molecules. If the molecules are moving more rapidly, but the pressure remains the same, then the molecules must stay further apart, that the increase... Hold on, let me try that again. Kinetic molecular theory states that an increase in temperature raises the average kinetic energy of the molecules. If the molecules are moving more rapidly, but the pressure remains the same, then the molecules must stay further apart, that the increase at rate... Yeah, okay, so temperature expands the gas. Isn't redundancy increasing temperature increases the average kinetic energy? Where did everyone go? I don't know, honestly. I have no idea. It is a bit redundant, but at the same time, you know, when it comes to the basics, it's good to be redundant. If we increase the number of gas molecules in the closed container, more of them will collide. Pressure remains constant, the volume must increase in proportion. Alright, so they are all just the basic like properties of gases explained with this model. Okay. Some important practical applications of KMT. The molecules of a gas are in a state of perpetual motion, in which the velocity, the speed and direction of each molecule is completely random independent of the unknown molecules. This fundamental assumption of the kinetic molecule model helps us understand a wide range of commonly observed phenomena. So diffusion, okay, once again, makes sense. Because every gas is a volume to another gas. So diffusion. Would you rather have a productive workstream or low productive and more interactive viewers? I'd rather have both. Is that way too much to ask? Can I not have both? I, by the way, also love that in the poll we got the same result for chemistry and electricity, which is basically this textbook. He's eating his cake and having to. I am making a listen, I am making a stream of baking a cake. Whilst eating a cake. I am baking a cake whilst eating a cake. That's a much better analogy. Okay. Stopcock. When the stopcock is opened. Wow, mate, warned me. When the stopcock is opened, random motions cause each gas to diffuse into the other container. After diffusion is complete, bottom, individual molecules of both kinds continue to pass in between the flask in both directions. Yes. Random motion molecules can lead to a complete predictable drift in their ultimate distribution. Yes, okay, so this is all simple. One application of diffusion is the separation of isotopes. Most important example is the enrichment of uranium in production of nuclear fusion fuel. Gas diffusion plant. Gas diffusion plant was a major source of the enriched uranium during World War II. Simply was the cages and 10 dials. Government project. Whoa, I love how in this textbook they're just dropping these facts. He's making his cake and eating it too, precisely. Diffusion of the molecule. Okay, so this is just all like consequences of these laws, right? Gases, like all fluids, exhibit a resistance to flow, a property of viscosity. Basic cause of viscosity is the random nature of thermal motion. All of these are just consequences of the laws. Yeah, okay. Alright. How long have we been streaming for? I'm really hungry. I should go and eat something. So yeah, I feel like that would be it for the day. Wait, I thought the sky is blue because ocean is blue. Yeah, that's actually why it's just government doesn't want you to know. Sky is actually the reason why. In fact, the reason why sky is actually blue. No, my parasocial relationship. I'm on Discord. We can have a parasocial relationship there. What do you mean your? What about my parasocial relationship? You only think about yourself, Andy. Yeah, more than I know. Oh, I'm really hungry. I wanna go. The server is ever so slightly inactive. There are people. The Quant is talking with Cole right now. I'm gonna go though, because I'm hungry. I wanna eat something. So yeah. that'll be it, I suppose. So, that was a fun live stream. Actually got some pretty decent work done. Have a nice day. You too. I'm gonna go, as always, work on videos, although I'm rendering right now, and there isn't really a good way for me to speed up. So, I just need to wait. Love it. It's great. Okay. For now, that'll be it. Thank you everyone so much for watching, and have a great day. Bye.